Okay, guys, please make sure you get your pens and notebook ready for our coming video. All right. Okay, so this is lesson 2. It's about outlier. Okay, so we're going to learn something about the outlier, and also we need to compare the mean and median in the coming video. All right. First, what's an outlier? Outlier is a data value that is numerically distant from the rest of the data, right? So, for example, here are the reaction time for 10 different persons. So here are 10 different persons and their reaction time. Okay, so reaction time means how much time it takes for one to react to a certain signal. For example, if you see one, if you are driving, you see one coming out across the road, and the time you react and you brake your car is that would be the reaction time. All right. So normal people, the reaction time would be around 0.2 to 0.4 seconds. So we see the data for 10 different persons. Okay, so you see for A to I, 0.2, 0.3, 0.2, 0.4, 0.3, 0.2, 0.4, and 1.6. Oh, okay, that's quite large. All right, sorry, I just need to add the seconds for the last two data. Okay, so first let's see which is the outlier. So it seems 1.6 is particularly greater than the rest of the data by it's such a great margin. It's quite significantly, right? Okay, so but for more precise measurement, let's write the data in ascending order. Okay, let's write the data in ascending order. Okay, so that will be 0.2. So that's the first data. Another 0.2. Okay, another 0.2. Okay, so basically we use this data, this data, this data. Okay, and then we have 0.3 and another 0.3. Alright, another 0.3. Okay, then we have 0.4, 0.4, and another 0.4, and then this one. Okay, why this 1.6 is what we call the outlier? Okay, because you can see for most of the data the separation is about 0.1, right? Okay, but suddenly the separation between 0.4 and 1.6, so that's the difference, is around 1.2. So that difference is significantly greater than the rest of the data. All right, so that's why we call it an outlier. Okay, so for A, identify the outlier. Okay, so the outlier would be our 1.6 seconds. Okay, so B, determine the mean and the median of the data with outlier. Okay, still remember how to find mean. Okay, if you forgot, you can go back to our video 1 to see if what's the definition of mean and median, right? Okay, for mean, we use this symbol, right? And we use this one. Okay, so how many data? There are 10, right? So there are 10 of them. So there are 10. Okay, so and then we add them up. 0.2. Okay, how many 0.2? There are 3, so I don't want to write all of them. So 0.2 times 3, that means 3, 0.2 add together, right? 0.3, again there are 3, 0.3, and also there are 3, 0.4 plus 1.6. Okay, let's calculate by using your calculator. Okay, right. Okay, so the mean is 0.43, and how about the median? Okay, so remember median would be the middle data. Still remember? So median, sorry, that's quite ugly. Median is the middle data. So where is the middle data? So we know that we use this formula. Okay, so it's location. The location of the median should be m plus 1, 10 plus 1 divided by 2. So the order would be this one. So that would be 5.5 data. So, but we don't have 5. So we don't have an exact location of 5.5, but you know 5.5 means between 5 and 6. Okay, so median would be 5th data plus 6th data divided by 2, right? Right, let's find out where is the 5th data. 1, 2, 3, 4, 5. So here's the 5th data, and that's 6th data, right? Okay, so 5th data 0.3, 6th data 0.3, and you add them and divide by 2. So that's 0.3 seconds. Alright, so mean is 0.43 seconds and medium 0.3 seconds. Alright, so that's when we calculate the data with that outlier. So when that's outlier, you calculate, you find the mean and median just like the method we used before. But what things can you notice? Okay, you see that when there's a outlier, this time outlier is significantly larger than the rest of the data. In this case, the mean is much greater than the median. Okay, actually you see the mean is 0.43, but for all the data except 1.6, okay, all other data are actually less than 0.4. So do you think that 0.43 is a good representation of what we call central tendency? Alright, you need to think about this. Alright, and so next let's have a look at determine the mean and median of data without outlier. Okay, so this time without outlier. So that means we need to rewrite our data. So the data is now 0.2, 0.2, 0.2, 0.3, 0.3, 0.3, 0.4, 0.4, and another 0.4. And since that's without outlier, so we don't need that 1.6. Okay, how could we find our mean? So this time, again, we add all the things divided by the number of data, but this time because we delete that, we have deleted that outlier, so that remains 9 data, right? So there are 9 of them. Okay, how many 0.2? 3 of them. Okay, so you see, in this case, okay, so the mean becomes much smaller than 0.43. Alright, and how about the median? Okay, for median, its location, you need to find the location of the median. The location is still, you need to find it, 9 plus 1. Remember that only 9 data left. Okay, that would be our fifth data. Okay, so where's our fifth data? It should be 0.3, right? So median is fifth data, and fifth data is 0.3. Alright? Right, so median is 0.3, and also mean is also 0.3. Okay, let's compare. First, we compare our mean. Okay, the mean is now significantly decreased from 0.43 to 0.3, but our median, when you compare the median, they are still the same. Okay, sorry, again I forgot to write the units. Okay, they are still the same. Can you see that? Okay, so what's the effect of outlier? Okay, so with outlier, in this case, the mean is much greater than when there's no outlier. But for median, with or without outlier, there's no effect on the median, right? So when you ask about the effect of outlier on the central tendency, okay, still remember what do we mean by central tendency of the above data? Okay, there are 3 things about the central tendency, namely mean, median, and mode. Okay, so mode is the most popular data, but now we're not interested in mode, so we only look at the mean and median. Okay, so what's the effect of outlier on the central tendency? So you could see on this, there's no effect on the median, but the existence of the outlier makes the mean much greater, right? So we might write the answer like this. The presence of outlier has no effect on the median, but makes mean much greater. Okay, so that's the answer. Alright? Okay? You understand? Alright? Okay, so if you have any trouble understanding this part, okay, you might pause the video and look back or rewind to make sure you understand this part. Alright? Because we are going to have another example. Alright? Okay, so before the other example, let's remember the conclusion of outlier. Okay, so outliers can greatly affect the mean value. It has little effect on the median. Alright, so greatly affect the mean value, little effect on the median. Why there is a great effect on mean value, but there isn't significant effects on the median? It's because when you are going to calculate the mean, you have to add that outlier, right? So if that outlier is significantly greater, then the rest of the data, of course, will increase the mean, right? Okay, but for the median, it's all about the physically central part of the data. Okay, we don't need to add all the data. You only need to find the central part of the data or the middle data. So in this case, because the outlier is either at the either at the greater n of the group of data, or the smallest n of the group of data. Alright, so that's why it has a very little impact on the value in the middle region of the data, right? Because it must appear at either end of the data, right? Okay, let's see another. So for question 1, we've seen the effect of rather great outlier. So let's see if there's another type of outlier which is relatively small than rest of the data. So let's see this one. Okay, time spent on taking shower. Okay, so different person spend different time taking shower. Okay, each day from group of 7 people. All right, so from A to G. Okay, so you see some A 15 minutes, 18 minutes, 20, 16, 22, 18, 6. Okay, so which data you think should be an outlier? Of course, it should be 6. Okay, but let's see why it must be 6. All right, so again, let's rewrite the data into its ascending order. For the ascending order, you start with 6 minutes. Okay, and then the next one will be 15 minutes, and 16 minutes, 18 minutes, 16 minutes, 18 minutes, another 18 minutes, 20 minutes, 22 minutes. Okay, so you see from 6 to 15, there's a difference of 9, right? Okay, from the rest of the data is only 1, the difference, the 2. There's no difference at all. 2, 2. So for the rest of the data, they are very close to the next data by 1 or 2, right? But for 6, the nearest data has a difference of 9. So that's you can see there's a huge gap between 6 and the rest of the data. So that's why we call 6 an outlier, and this outlier is different to the outlier we've seen before, because this outlier is rather small outlier. Okay, when you compare with the rest of the data, 6 minutes. Okay, determine the median and the mean of the data of the outlier. Okay, determine the median and the mean data with the outlier. Okay, with the outlier. Okay, so how could we find the mean? Okay, mean is this one. Again, you need to add all the data divided by number of data. Okay, so we know this time there are 7 data. Okay, 7 data. Okay, and 1/6, 1/15, 1/16, 2/18, so 18 times 2 plus 20 plus 22. Okay, use your calculator. Okay, so the mean would be 16.4, so we only correct to 1 decimal place minute. Alright, so how about the median? So median, you need to find the middle data. So you need to find the location first. So what's the location? Because that's 7 data, so 7 plus 1, that's TH indicating that is about the locations, not the data itself. Okay, so that's 4th data. Remember, when you find that the location is the fourth data, that doesn't mean the data is 4. You need to do some counting from 1 to 4, right? So first data 6, second 15, third 16, and fourth 18. Right, so median is 18 minutes. Okay, so again you see median is greater than some appreciable margin than mean. Why? The reason is you have a particularly small data as an outlier. So this time the outlier is relatively smaller than the rest of the data. So this outlier makes the mean smaller than the median. So in the last case, if you have a rather big outlier, then the mean would be greater than the median, but this time just reverse. Alright, determine the median and mean without outlier. Okay, without outlier. Okay, so with the outlier, without the outlier. Alright, so without outlier, let's see. So possibly we need to rearrange a little bit of our data. Okay, so I have the advantage of copying. So the data now I have is, because I need to delete that outlier. Okay, so without outlier that would be only 6 data. Okay, let's find the mean. Alright, should be using the same method. 15, 16, 18, 18, 20, 22 divided by 6. Okay, so let's find the median. So for median, its location should be 6 plus 1 divided by 2. So 3.5. So 3.5 is between 3 and 5. Yeah, so median, you need to find third data plus fourth data and divide by 2. Okay, so what's the third data? So it should be 18, another 18 divided by 2 should be 18 minutes. Okay, so let's compare this time. Without outlier, you see that mean actually is very, very close to the median, and the median actually does not change from previous median. Okay, so state the effects of outlier on the central tendency. Okay, so let's do the comparison again. Okay, with outlier, the mean is 16.4. Without is 18.2. Alright, so without outlier, you see the mean becomes greater because the outlier is a smaller outlier, it's not a big outlier. Alright, okay, so let's see the median. With outlier, it's 18. Without, 18 again, so there's no effects whatsoever, okay, on the median by the outlier. But of course outlier has significant effects on the mean. Alright, so we can say okay, change the color. The presence of the outlier has no effects on the median, but it reduces the value of mean. Okay. All right. Okay, make sure you understand. All right. Oh, good. Okay, let's move on. Okay, so before we start our second half, you possibly need to take a break to or look back to what we have learned. All right, so please have a 5 minutes break. All right. Okay, let's continue now. Okay, so compare mean and median. Okay, so we know that when there's no outlier, okay, mean and median should be very close and equally representative for the center of the data. We know that's when we call the representative for the center of data, that means central tendency. We have 3 statistics for central tendency, namely mean, median, mode, but normally we don't use mode. We use mean and median, right? But the problem is when you have outlier, then the situation will change. When there's outlier, either the outlier is particularly bigger than the rest of the data, or particularly smaller than the rest of the data. Whatever it is, if there is an outlier, the medium becomes more representative because the medium is not going to be affected by the presence of an outlier. Okay, so remember this: if there is no outlier, then mean and median are equally good for the central tendency representation. However, if there is an outlier, we need to use median. Alright, so that would be the general rule. Okay, try to understand this, make sense of it, and try to get that into your head. Alright, so let's compare 2 sets of data. Alright, so there are 2 sets of data regarding monthly salaries of 8 staff in 2 different companies. Right, so for the company X, you got the lowest 32,000, the highest the lowest is 3,200, the highest is 12,000. Alright, so huge difference, right? And company Y, the lowest is 4,000 and the highest 8,000, right? So there are 2 companies, right? Identify which set of data has an outlier. Okay, so you need to notice that the data is already in ascending order, so you don't need to rearrange them. Okay, so when they are in ascending order already, so you see, are there any particularly small data? Okay, so you can see, so that's the difference is 400, okay, 0, 1000, 0, 1000, and here 6000. Okay, so of course you see the 6000 is quite large, right? Isn't it? Okay, so this one should be outlier. Alright, okay, let's see another set of data. Different 0, 0, 1000, 0, 1000, 1000, 1000. Okay, so in this case, the difference is either 0 or 1000. Okay, so you see, there's no huge difference among the data. Okay, so there's no outlier in the second set of data. Identify, so for A, identify which set of data has an outlier. Should be, your answer should be set company X, right? Which set of data? So you can't answer 12,000. Okay, so that's the outlier, but we are asking you to identify which set of data. Okay, so your answer should write company X. Find the percentage difference between the means of X and Y. Okay, so you need to find for X, you need to find the mean. Okay, alright, so there are how many data? 1, 2, 3, 6, 7. All right. Okay. So that to 4000, just some space. You can save some space. Plus, okay. So you need to use your calculator now. Okay, so that's the mean. Okay. Do you think that's mean is reasonably central of the data? I don't think so, because you see, most of the data actually, except two of them, are less than that. Less than that 6,100, right? Okay, so only two data are actually greater than that, so it's not at the central part of the data, right? Okay, for y, okay, so the mean is, it should be the second set. All right, so second set is 4,000 times 3, 5,000 times 2, 6,000, 7,000, 8,000. All right, divided by 7 again. So let's see what are we going to have. Plus divided by 7. Okay. Oh, sorry, 9. Okay, so let's see. Find the percentage difference between the means of x and y. Okay, so percentage difference. Okay, we might use the bigger one. That's of y minus that's of x. Because that's about percentage, you need to divide the value of x. Okay, so the percentage is quite small, alright? Okay. Sorry, I need to change that into percentage, so that means you need to multiply that by 100%. Okay, so the percentage is quite small, so that means the two mean really close. Alright, okay, so let's see. Find the percentage difference between the medium. Okay, so we need to find the medium. Okay, for x, so the location of medium should be, there are seven data. So this one should be fourth data. And the fourth data of x is 1, 2, 3, 4. That's 4,000. 4,000. Okay, for y, so the location again would be the same, which is the fourth data. And the fourth data for y is 5,000. Okay, so let's see percentage difference. equals, again, we use 5,000 minus 4,000 divided by x, okay? So 25%. So that means y is actually greater than x in terms of median by 25%. But y and x have very similar mean, alright? So, okay, so last question. Boss of company X claims that he pays better for his staff than Y does. Okay, explain whether this claim is justified. Okay, so you see that for X, you got smaller, so smaller mean, and also you got smaller median. And of course, we need to use median because this time there's an outlier in X, so we should be focused on the median. So when you compare the median, Y is much greater than X. So of course, X, the claims by the boss of the X is very wrong. All right, okay. So remember, when you explain it, you need to state that's what statistics are you going to use. Are you going to use mean, or are you going to use median? Okay, in this case, you should use median. Okay. Okay, so you need to explain it. So, okay, since let's say there is an outlier in the data of X, median should be used to compare the central tendency. Okay. As the median of Y is 25% greater than that of X. Okay. Y pays better than X. So therefore the claim from the boss of X is wrong. Alright. Okay, so that will be our second example, alright? Okay, hope you have understood most of the ideas. Alright, so if you are alright with the examples here, please try to do practice 2. Okay, and please, after you finish your practice, please try to take photos and send them to the homework folder in the OneNote. Okay, thank you very much. See you next time.